The other thing you have to remember that this is called the principal quantum number. This is called the magnetic quantum number. This is called the azimuthal quantum number or the orbital angular momentum quantum. This can take a value depend like if this is 1, it will take a value 0. That's why you only have, and if it takes 0, you will have only one S. This if it's P, it will be if it's 1, it will be P, and if it's D, and here if F3 is F. Now each of these has got three magnetic quantum numbers. P will have three. There's a reason for that. I'll explain later. This is Px, Py, Pz. Similarly, this will be dx square. There are five orbitals of Z of D, and then there was seven of this. So effectively, what happens is that because the first can only have uh, L as 0 because there's a rule. The L is n minus n1 or 2, 0 to n minus 1. I'll show you those rules. So if n is 1, 2, 3, 4, which is for KLMN, the azimuthal quantum number can take a value from 0 to n minus 1. Like if n is 1, and it will take only n values because 0 is included, 0 to n minus 1. So here n minus 1 would be 1 minus 0. So it's 0. And if it's 0, you will only have S. 0 is for S. 2, n is 2. So n minus, it will be 0 and 2 minus 1, which is 1. So that means 0 and 1. So these has 2, these two, 0 and 1. And the third will have 0, 1, 2. And the fourth will have 0, 1, 2, 3. Now this represents the S, P, and D shell. The other thing, the magnetic quantum number, it will have, so it will have, just notice whatever are the what's the number of the orbit of the shell, you will have the same number of subshells. They will be, so like there are two shell, there will be two subshells. There are four shells, so there will be four subshells. S, P, D, F. Then the magnetic quantum number is how it degenerates into divides into orbitals will be between, it will be like this: 0, L, minus L to plus L, minus L, 0, minus L to plus L. So like it's 1, it will be minus 1, 0, plus 1. If it's 2, if 3 is, it will be, uh, sorry, for 2, it is minus 2 to plus 2, 0, and there will be 5. So these are the d orbitals. And the shape of the d orbital is these. There are, px, py, pz. So here it will be, it's in the plane, and these four are similar. These four are similar. Xy, xz, they are in this plane. Xy, they are in the xz plane. Xz plane. This is yz plane. Uh, this is on the axis x square dash y square or minus y square, and this is the only different. Dz square is different. The other five are same. And of course, px and py are along the axis px, py, pz. Understood?